Hi everyone, it's Mr. Hanna back here. Okay, we're going to continue learning about expanding quadratics. In particular, we're going to look at the difference of perfect squares. A very important result for us. First off, let's start with an example similar to one from last time. So suppose we're asked to expand x plus 6 multiplied by x minus 1. Okay. Well, what we've got to do, we can use our special trick and say that it's x times x first. That's our x squared term. And we've got plus 6 minus 1. So if we add those together, we get plus 5. So our middle term is plus 5x. And plus 6 times minus 1 is minus 6. So that's our result that we got from last time. And it leads to our general rule of whenever we expand x plus a number, let's call it a, times x plus a different number, so we'll call it b, we always get the result of x squared plus whatever you get when you add a and b, that's a plus b, x, and then whatever you get when you multiply a and b, plus a times b. There we go. So that's our general result that we got from last time. Now we're going to look at another special case. Okay, so let's look at this next special case, and it's called difference of perfect squares, or DoPS. So let's start with an example. So let's start with x plus 3 times x minus 3. Notice that what's going on here is we've got a plus 3 and a minus 3. Same number, but different sign. So let's expand this using our trick that we've got in red, our shortcut trick. So we've got x's, so it's x squared is our first term. X squared. Then we're going to add a and b. So in this case, we're going to add plus 3 and minus 3. So we're going to add them, 3. And now adding a minus 3 is minus 3 times x. Now we're going to multiply them together. So plus 3 times minus 3. Okay, so we're going to multiply 3 times minus 3. 6 up by 3. Okay, let's simplify this down. And you can see what's going to happen. We've got a plus 3 and a minus 3. So this entire term here disappears because it's 0. So then we've got plus 3 times minus 3 is minus 9. Minus 9. Okay, so you can see fairly clearly from this example what's going to happen for every case. For every case, whenever we've got an x plus a number, multiplied by x, take away that same number, it's always going to equal x squared, then take away whatever the number was squared. Take away a squared. And that will always be the result. So if we were to do, let's do a couple of examples now. So maybe we'll do some examples. We'll start here. Example 1. Okay. So suppose we had x plus 5 multiplied by x minus 5. And we want to expand it. It's x squared minus whatever that number is squared, which is 5, so that minus 25. Okay, so that's quite a straightforward, easy example. Okay, let's look at some examples that might be a little bit harder. Let's go with x plus 2a multiplied by x minus 2a. So here a could be any number, just a mystery number. So we've got x's here, so that's x squared. Now minus 2a squared. So that gives 2a squared is minus 4a squared. There we go. So it's whatever we had here, whatever this is, squared is that second term. Okay, let's look at another example. Example 3. Alright, what if we had 2x minus 4 multiplied by 2x plus 4. Okay, so what's going on here is, instead of just x, we've now got 2x on both of these. Instead of x, we've got 2x. Alright, so instead of just x squared, it's going to be 2x squared. So that's the bracket, 2x squared minus 4 squared. So that's 4x squared minus 16. There we go. And if you want to, yep, let's leave it there. Okay, why not? One last example. Example 4, just for those who may want it. Okay, x minus 2 root 7 times x plus. Come on. What's going on? Plus 2 root 7. Alright, it's going to be the same thing. X squared minus 2 root 7 squared. Now, hopefully a few people are familiar with their surds for this one. X squared minus, so it's the 2 squared first. 2 squared multiplied by root 7 squared. X squared minus 4. Now, root 7 squared is, of course, 7. Square root and squared are opposites of inverse operations. Okay, 4 times 7, 28. So that's x squared minus 28. And there we go, that's plenty of examples. Just as a little taster for next time, you can also go backwards. So let's consider, this is a bit of getting a bit ahead of ourselves, but let's do it anyway. Suppose we wanted to factorize, so we wanted to go the other way, put brackets in, and we had x squared minus, let's make it something pretty easy, minus 16. Well, what we can do is we can say, oh, well, 16 is obviously 4 squared. Now we can do the backwards. We can work backwards. X minus 4. Oops, what am I doing? There you go, so we can work backwards if we want to using our difference of perfect squares. So there we go.